That's a good way to phrase it. So looking at worksheet 3, or notes 3, I should say. Notes day 3, August 22nd, original recording date. I can take the derivative of 2x to the 11th. That's easy. The rest of these aren't in the right format, so I need to change them up so that they are powers, or exponents, not square roots and denominators. So I need them all to be powers. 2x to the 11th minus 12x to the 3/4 minus 6x to the negative 5 minus 14x to the negative 2/7. Algebra.
Like for the negative 12, and the second one, can you go over that one a little more detail, how you did that?
Yes. The top number is the power, the bottom number is the root. Right? The flower power grows on top, and the root grows underneath. So the power is on top, the root's underneath. So this is a fourth root, so the 4 goes in the bottom. The power is 3, so the 3 goes on the top. Do you need the hand motions to go with it as well? Flower power, root goes underneath. Alan?
For the negative 6, this will become negative 6 after you bring up the x.
Oh. Of course not. Good question. Like, where did the negative come from? All right, so you try that one real quick, and I'm going to take attendance, and then I'll pull some popsicle sticks. That's how I would leave the answer. If it's multiple choice, it's probably going to have negative 9 and the fourth root of x in the bottom, 30 over x to the 6th, 4 over, would that be the 7th root of x to the 9th? So I would never write it that way, but a multiple choice test might write it that way. So again, make sure you're comfortable with the flower power stuff and the negative exponents. So it's like there's an algebra step and then a calculus step and then maybe another algebra step at the end, if you needed to match up to whatever format the test looks like. Number 2, consider the function given by. What is the slope of the line tangent to the point when x is 1/3? That's a lot of words to be asking. What's it asking? Find the derivative at 1/3. So today is really an emphasis on making sure you understand the terminology, but you're still finding a derivative every single time. I think we've got an algebra step first here. Let's divide each of those by x. 6x squared minus 8 plus, how do I divide 3 by x and end up with a exponent? Yeah, 3x to the negative 1. And again, we really wouldn't like that format, but it's the format that allows us to take a derivative. So I'm not even going to press pause on the recording before I ask for these, because I think they're easy enough. No pressure. Kira, what's the derivative of 6x squared? 12x. Very nice. Mia, what's the derivative of negative 8? Nothing. Good. So you could leave it blank. I'm going to put a plus 0 there just to sort of emphasize that the derivative is 0, but that is not necessary. Amy, how about the derivative of 3x to the negative 1? Negative 3x to what power? Yes, there you go. Negative second. I don't think I've heard it phrased that way, but that's correct. So is that the answer to my problem? Not quite. That's the derivative, but I want the derivative when x is 1/3. So what do I need to do? Plug in 1/3. So 12 times the third. I'm going to leave out the 0 now. Minus 3 times 1/3 to the negative 2. That would be a safe stop. the key or the answer, the test, multiple choice would definitely not leave it like that. 4 minus, if I square the 3 and flip it over, it's 9. 4 minus 27 is negative 23. So I almost said negative 23 is the better answer. That's not true. Negative 23 is the multiple choice answer. Substituted but not simplified is the safe stop answer. So again, kind of depends on the situation which one you would use. Occasionally we will use the derivative to do other things in the problem, and if that's the case, you probably don't want to be carrying this throughout the whole problem. You probably want to simplify that and then just use negative 23 the rest of the way. Number 3, find the values of x where the graph has a horizontal tangent line. Oh, we haven't done one quite like this yet. Show me with your arms what a horizontal tangent line looks like. Good. What's the slope of a horizontal tangent line? 0. Well, if the slope is 0, what else is 0? The derivative. So that's really a fancy way of asking where is the derivative equal to 0. To have a horizontal tangent line. So once again, I need to take a derivative. Like all these problems are, take a derivative and then basically reread the question and make sure you answer what they're asking. So another one where I've got to divide everybody by x. Whoops, divide everybody by x squared. So 5 minus 4x to the negative 1 minus 2x to the negative 2. Flying through the popsicle sticks today. Leo, Ava, Ian. Leo, what's the derivative of 5? 0. I mean, yes, that's the easy one, but that is sometimes people forget and they just drop the 5 down. You're like, come on, that's the easiest one. Ava, how about the derivative of negative 4x to the negative 1? 4x to the negative second? Is that really the right way to say that? I don't know. Amy's infected all of us now with that phrasing. Hope infected is an okay word there. Ian, how about the derivative of negative 2x negative 2?
4x is higher than 3.
Good, 4x to negative 3. Now, if it just asks for the derivative, that'd be a perfectly fine safe stop. But it wants to know where that's equal to 0. I can't really tell where that's equal to 0 the way that's phrased. So I'm going to redo this as 4 over x squared plus 4 over x cubed equals 0. Now, I've still got some algebra to do, but at least I don't have negative exponents anymore. What would you like to do to solve this problem? I see a couple ways you could go here. What could we do? Too early? Gregory, you were on the verge of an idea there? Alan? It can't be 0 because if we plug in 0, we get undefined. Right? So undefined plus undefined, that's definitely not 0. So the answer is not 0. Ian?
You could take 4 over x squared and put it on the other side and then cancel out one of the x's.
Okay. Oh, yes, that would work. So Ian says let's move the 4x squared to the other side. Right? Is that what you said?
Yeah.
And then I'm going to hijack your solution. If I get there, I think we should cross multiply. 4x squared equals negative 4x cubed. I kind of don't like this because what we're about to do is works here but doesn't always work. If you divide both sides by x squared, that's a dangerous game because you're dividing by solutions. let's jump back here. Let's just get a common denominator. This will better fit with the way we ask the questions later. So that first one needs an x top and bottom. So 4x plus 4 over x cubed equals 0. All right, my okay and no 0 experts. What makes a fraction equal to 0, the top or the bottom? The top. So the bottom can't be 0, and if the top is 0, that would be -1. So this means when x is -1, that curve has a horizontal tangent line. Yes? This problem deserves the stamp because there was one calculus step in the whole problem. The rest was algebra. It's like 1/5 calculus and 4/5 algebra. Number 4, consider the curve given by that thing, and what value of x is the slope of the line tangent of, at what value of x is the slope of the line tangent to the curve equal to 2? That's a mouthful. What's it asking me? What's that question mean? Yes. Where is f prime equal to 2? So take a derivative, set it equal to 2. Why don't you try that one, and then we'll see what we get. The other one is going to be kind of yucky with the negatives and the squareds and the fractions. But let's see. I got to move the 9x squared over, multiply by 9. Divide by 9 to get x squared by itself, and then square root both sides. And sure, that can be simplified a couple different ways, but we don't care about that. That's a safe stop. Root 3 over 9 if we went all the way with it, finish the algebra on it, plus or minus. So I kind of breezed through the algebra there at the end, but I expect you to be able to breeze through the algebra there at the end. Like if that's a sticking point for you, then this whole year is just going to be a real rough time for you. Like you got to be able to just cruise through the basic algebra stuff. Yes, sir.
So these are the points when it says 4x, it kind of brings the kind of 5 plus 2. Couldn't we just plug in 2 there and still get the right answer?
You're not, well, it's not when x is 2, you want the answer to be 2.
Oh.
So you're setting that equal to 2. So if x was 2, then you would plug in 2. But this is saying the slope is 2, so all of this is equal to 2. Number 5, write the equation of a tangent line. We do this. That instruction will be given at least probably on 3 or 4, probably average that question once a day for the next month or so, because that's something we like to do. Find the equation of a tangent line. Let's back up and review equations of lines. What's one equation of a line? You may not know what I'm asking here. Y equals mx plus b. That's usually students' favorite because it's the easiest to graph. But it is not our favorite in calculus. Not at all. We much prefer point slope form. Y minus y1 equals m times x minus x1. Because you don't need b to write that form, you just need the point and a slope, hence the name point-slope form. So if you can find a point and find a slope, then you can use point-slope form. And to find the slope, they usually give us the point. Slope, we know, is the same thing as derivative. So it's yet another way to get you to find a derivative. Okay, so I need a point and a slope if I want to write a tangent line. So the point, they tell me x is 3. How can I find the y value? If I know x, what can I do to find y? Just plug in 3 for x. So g of 3 is 2 times 9 minus 4 times 3 plus 5. 18 minus 12 plus 5. 6 plus 5 is 11. So there's my point. 311. But I also need a slope now. But I find the slope by finding a derivative. I feel like this problem was probably supposed to print on the next page. G prime 4x minus 4. So how do I find g prime when x is 3? Plug in 3. Do not write your slope as 4x minus 4, because that's the slope at any particular point. We want the slope at 3. So when we go to write this equation, we don't want to put 4x minus 4 in for slope. We need the slope at 3. So let's see, 12 minus 4 is 8. So now I've got all the pieces I need. Y minus 11 equals 8 times x minus 3. And because we like that form, we don't simplify that. We just leave it as is. And even if you needed to graph it, it would be easy to graph, because all you would do is go to the point 311 and use a slope of 8. So we like point slope form. Make sure you relearn or reaccustom yourself to the point slope form, because we will be using it again and again and again and again. Again, that was the derivative of 2x squared minus 4x. Cramp on my space here. Oh, yeah, that definitely should have been printed at the top of the next page. We'll skip number 6 just because it's the same thing. Number 7, a relative extremum. Do you remember what a relative extremum means? Have we even talked about that? Let's see. X cubed. So I know generically what x cubed looks like, what an x cubed graph looks like. A relative extrema is the top of a hill or bottom of a valley. So just like conceptually, picture-wise, I might have 2 relative extrema for a cubic. I say might because, there's some cubics that don't do that. They don't have peaks and valleys. They just kind of go straight through. Okay, here's the big connection. What's the slope? What's the slope of a tangent line at a peak or a valley? If I put a tangent line on there, right? So tangent line sort of traces out where the curve is. So the tangent line at the top of a hill is 0. Or the slope of a tangent line is 0. Same thing at the bottom of a valley. The slope is 0. So relative extrema is another way of asking where is the derivative 0. So I guess it's a new term, but it's still using the same process. Where's the derivative equal to 0? So, Anders, what's the derivative of our function? I'll let you do all 3 pieces because it's an easy one. Yeah.
12x squared plus 4x.
Good. 12x squared plus 4x. And I want to know where that's equal to 0. Because where the slope is 0, I might have a relative extrema, top of a mountain or bottom of a valley. So I can factor out a 4x. And then set both of those equal to 0. So Kylie, what are my 2 answers? Get you the algebra question.
0.
Okay.
-1.
Very nice. So new term, kind of, but same process as always. Lots of derivatives, but lots of ways to ask you to find the derivative. All right, 8 through 12, really concept-heavy questions. There's no calculations to do. It's just you understand what things mean. What values of x satisfy f prime equal to 0? Remember, f prime is slope. So what values of x have a slope of 0? Yeah, 0, n, and p. Because all of those would have horizontal tangent lines. Slope is 0. On what intervals is f prime negative? On what intervals is the derivative negative? Well, derivative, same thing as slope. So we could just ask, on what intervals is the slope negative? So what's an interval where the slope is negative? Between n and p? Yeah, that's a positive slope. Between 0 and n. And then from p, and I think we can just assume infinity, it just goes on forever. If the slope's negative, another way to say this, we'll harp on this later, would mean that f is decreasing. That's sort of the same thing. On what intervals is f prime positive? Monty, give me an interval where f prime is positive, where the derivative is positive, where the slope is positive. Pardon? Okay, from n to p. I like that answer. Is there any other intervals where the f prime is positive? Be careful, negative infinity to 0. This would have been a fun one to. So f is increasing, negative infinity to 0, n to p. F is decreasing. Need to get more highlighters here on those 2 intervals. Purple doesn't show up as purple.
Do you not use brackets for any of these?
This came up in the Facebook group the other day, and basically it depends on. I'm in real fun Facebook groups where we talk about whether to use parentheses or brackets on increasing and decreasing intervals. If I remember right, different textbooks define it differently, and based on that definition, some people say that it's parentheses and some are brackets, and because of that, AP test is not going to take off either way, because they recognize that if your teacher did get that technical, it doesn't matter because different books use different things. So I would be okay either way.
Isn't the slope at the tops and bottom 0 anyway?
Yes. So that's the argument for not including it. right? Because the slope is 0, so it's not positive. The slope isn't positive there. But if you're talking about intervals, that's a little bit different thing. So it increases all the way to 0, including 0. If I stopped at 0, we increase all the way till we get to 0. That's the two counter arguments right there, and that's why people get confused. But the basic answer is it doesn't matter. Yeah, College Board is not going to give you a multiple choice where on this type of question where one set of answers has parentheses and one has brackets. They're not going to test that. Okay, number 11. On which interval is f prime greater than 0? No, not f prime. F greater than 0. What does that mean? Good. So the y value is greater than 0. And f prime, so the slope, is negative. So I want my y value to be greater than 0, but my slope to be negative. So I need a positive y value, but a negative slope. And it helps to process all that stuff out loud, because then that helps clarify what you're looking for. If all you do is read those, you're probably going to miss the problem, because that's too technical. But you start translating it into words. So I need a positive y and a negative slope. Okay, I think that's easier to find. So what interval has a positive y and negative slope?
1 to 2.
Careful. 1 to p is a positive y but a positive slope. P to infinity is a negative slope, but there's some negative y values in there. So I just need to go p to 2. And again, the parentheses are brackets. I'm just going to go parentheses. I wouldn't want to include 2, because that definitely does not have a positive y value. But so you could argue that you want a bracket on p, but again, not really. We're not worried. All right, you try the last one, and then we'll be done. 3 minutes to spare. Where is the f less than 0 and f prime greater than 0? F less than 0, f prime greater than 0. Nick, you're the last popsicle stick for the day. And that will put everybody back on the draw side for tomorrow. So Nick, give me an interval where y's are negative, but the slope is positive.
Negative is equal to 0.
Keep going. There's one more interval. Gregory, you're whispering things at him. Is it because you know the answers? Or are you just harassing him?
I was encouraging.
You're encouraging. Quinn, what's the other interval? Into 1. You okay, Nick? You see where that is?
Yeah.
Below the axis, but we're increasing. All right. So not a whole lot new today. Maybe some new words. Maybe a refresher on point-slope format. But not a big deal. Worksheet 1 and 2 is due tomorrow. Oh, you need the worksheet for today, don't you?